can you solve this geometry challenge? Here's the question. Given this square, let's put an equilateral triangle inside of it. Now, the area of this blue triangle is 23 square units. The area of this red triangle is 22 square units. And what we need here is to find the area of this green shaded region. Now, pause this video right now and see if you can answer this question, because I will show you the answer and the solution in 3, 2, 1. Alright, the answer to this question, the area of this green region, simply equal to 7 plus 4 times square root of 3 square units. And now, if you don't get this answer, let me show you some hints. So the first hint is the double angle identity. You need to use trigonometry to answer this. But of course, you can use pure geometry to answer this. But if you use trigonometry, you need to be able to use the double angle identity, sum to product identity, and the Pythagorean identity. Now, pause this video again and come back to this video if you get the same result. And now, let's answer this question together. So, to answer this question, what we're going to do is to find a simple technique. To find the area of this green region, what we're going to do is to find the area of the whole square minus the area of the red triangle minus the area of this equilateral triangle in the middle minus the blue right triangle. That's it. We now have the area of this red and blue right triangle. So what we need is to find the area of the whole square and the area of this equilateral triangle. Once we do that, then we're done. And in order to solve for the value or the area of the square and equilateral triangle, what we're going to do is to create a rectangle on the bottom part like this. Now, let's call this angle right over here, this small angle, let's call this as alpha. Now, we will use this concept of trigonometry. If we have this right triangle and an angle theta, we can say that sine theta equals to the opposite side over the hypotenuse, and the cosine theta is the adjacent side over the hypotenuse. But if we're given the length of the hypotenuse, we can say that the opposite side simply equal to hypotenuse times sine of alpha, and the adjacent is hypotenuse times the cosine of theta. Now, for example, we have a right triangle right over here, and let's have the hypotenuse as h, and this angle, let's call this as theta. Now, the opposite side simply equal to h times sine of theta, and the adjacent side of this angle is h times cosine of theta. So we will use this concept to answer this question. So let's begin. Now, let S be the side of this equilateral triangle. So therefore, each of this side must be equal to S. Now, we have here a right triangle on the bottom part. So the adjacent side of this angle alpha simply equal to S times cosine of alpha. And since this is a rectangle, this side right over here on the bottom part is also equal to S times cosine of alpha. And this also the side length of our square. Now, we know the angle of this equilateral triangle is 60 degrees. And now the question is, what is the measure of this angle right over here? We know this is a 90 degrees. So this adds up to 90 degrees. In short, this angle right over here must be equal to 30 minus alpha. So 30 degrees minus alpha plus 60 degrees plus alpha, this is exactly 90 degrees. So if this angle is 30 minus alpha, the adjacent side of this angle must be equal to S times cosine of 30 degrees minus alpha. And the opposite side is S times sine of 30 degrees minus alpha. Now, in this right triangle, if this is alpha, this is 90 minus alpha. We know this angle right over here is 60 degrees. Now, how about this angle right over here? This is just a straight angle, and straight angle adds up to 180 degrees. In short, this angle right over here must be equal to 30 degrees plus alpha. Now, the adjacent side must be equal to s times cosine of 30 degrees plus alpha. And the opposite side must be equal to s times sine of 30 degrees plus alpha. And now, from here, let's solve for the value of s and find the area of the green region. And in order to find the value of s, we will use the concept of the area of a triangle. So 1/2 times base times height. So using the area of this red triangle, we can say that 1/2 times s times cosine of 30 degrees minus alpha times s times sine of 30 degrees minus alpha equals 22. Simplify. And now what we're going to do is to multiply both sides by 2. Why we do that? Because of this identity. Our first hint, the double angle identity. Because if we have 2 times sine theta times cosine theta, is equivalent to sine of 2 times theta. In short, our equation simplifies to s squared times sine of 60 degrees minus 2 alpha equals 88. Now, we will do the same thing to the area of this blue triangle. And if we simplify this, using again double angle identity, we can say that s squared times sine of 60 degrees plus 2 alpha equals 92. Now, let's set aside these two results. Now, at this point, what we're going to do is to add these two results. Because if we factor out s squared, we have s squared times sine of 60 degrees plus 2 alpha plus sine of 60 degrees minus 2 alpha equals 180. And this expression right over here is very familiar because if we have sine of alpha plus beta plus sine of alpha minus beta is equivalent to 2 times sine alpha times cosine of beta. In short, we can simplify this equation as 2 times sine of 60 degrees times cosine of 2 alpha. Now, we know the value of sine of 60 degrees. This is just square root of 3 over 2. Now, simplify. 2 is cancelled out. This is just 1. Divide both sides by square root of 3. Now, rationalize the right-hand side, and we can say that s squared times cosine of 2 alpha equals 60 times square root of 3. And again, let's set aside this result. Now, instead of adding these two equations, why not subtracting these two results? Now, factor out s squared. And again, this expression right over here is very familiar because sine of alpha plus beta minus sine of alpha minus beta is equivalent to 2 times cosine alpha times sine of beta. In short, we can simplify this as 2 times cosine of 60 degrees times sine of 2 alpha. Now, cosine of 60 degrees, this is just 1/2. Simplify, and we can say that s squared times sine of 2 alpha equals 4. And using these two results, we can now get the value of s, or s squared. Because we know the Pythagorean identity states that sine squared theta plus cosine squared theta equals 1. So if we square this and add these two together, we arrive at this equation. Now, factor out s raised to the 4th power, and take note, sine squared 2 alpha plus cosine squared 2 alpha, this is just 1. And also take note, 4 squared plus 60 times square root of 3 squared is 10,816. Again, this is just 1, so we have s raised to the 4th power equals 10,816. Get the square root on both sides because we need here s squared, so s squared equals 104. Now, we have the value for s squared. And using these three results, we can now get the area of this green region. So let's do that. So to find the area of the green region, we need to have the area of the square minus the red triangle minus the equilateral triangle minus the blue triangle. And the area of the square simply equal to s squared times cosine squared alpha because the side length is s times cosine alpha. This red triangle is 22 minus the equilateral triangle. The area is s squared times square root of 3 over 4 minus the area of the blue triangle, which is 23. Now, we now have the value for s squared, so there's no problem at all. But we don't have the value for cosine squared alpha. But take note, cosine squared theta is simply equivalent to 1/2 times 1 plus cosine of 2 theta. In short, cosine squared alpha simply equal to 1/2 times 1 plus cosine of 2 alpha. We know the value of cosine 2 alpha. This is just 60 times square root of 3 divided by s squared, which is 104. So, simplify this, we can say that cosine squared alpha simply equal to 26 plus 15 times square root of 3 divided by 52. Now, we can now have the area of the green shaded region because we now know s squared and we now know cosine squared alpha. Plug in all those values and we get that the area of the green region, if we simplify this, simply equal to 7 plus 4 times square root of 3 square units. And that is the answer to this question. Therefore, given this figure, then the area of this green shaded region simply equal to 7 plus 4 times square root of 3 square units. And as always, we are done.